In this fourth module of Chapter 10, Module 10.4, I show how life table methods can be used in the context of invasion biology. A generic underlying concept of all actuarial models, including life tables, is that of the risk of a negative occurrence, in other words, death, illness, or damage. Generally, risk can be defined as the probability in a change of state, and life table concepts can be brought to bear on a wide range of problems involving change of state. One example in which life table methods have only recently been applied, but in which the concepts and methods are relevant, is in invasion biology. For this case, cities, or more generally regions, can be considered as individuals that are at risk of experiencing a change of health state, according to their pest invasion status. For example, the health status of a city that has never experienced a pest fruit fly outbreak would be considered much differently than a city that has experienced multiple fruit fly outbreaks over a series of years, particularly because the city that has had many outbreaks may require the long-term use of chemical pesticides for pest control. In this module, I show how to bring life table methods and concepts to bear on the data from the fruit fly invasion of California that started in the middle of the 20th century and continues into the 21st century. In the mid-20th century, California began experiencing outbreaks of a number of exotic fruit fly species that are some of the most noxious agricultural pests in the world. These species are in the dipteran family Tephrididae, including the oriental fruit fly and two species discussed earlier in this chapter, the Mediterranean fruit fly and the Mexican fruit fly. The fruit fly invasion problem is approached by considering California cities as a cohort of pristine, that is, healthy individuals, subject to the risk of experiencing a fruit fly outbreak, that is, transitioning to the first of several unhealthy states. In 1950, no city in California had experienced any fruit fly outbreaks. However, by 2016, a total of 331 of the 478 cities in the state had experienced at least one outbreak. Some of these outbreaks were due to invasions of new species, and others were recurrences of previously detected species. Of the 331 cities that were infested between 1950 and 2016, a total of 189, 122, 91, and 60 of the cities experienced 2, 3, 4, and 5 outbreaks, respectively. The data for the 331 California cities in which one or more fruit fly outbreaks have occurred are presented in a life table format in this table. Note that the first column contains the year from 1950 through 2015. The next three columns contain the number of cities that remain uninfested, either 1, 2, or 3 levels of outbreaks. These numbers are converted to fractions of the original in the last 3 columns in this table, which effectively represent the survival or LX columns of a life table. Note that we start with 1950 with 331 pristine cities in all categories and the radix of 1.0 in all categories. By 1970, there were 321 cities that had yet to have a single outbreak, 329 cities that had yet to have 2 outbreaks, and 330 cities that yet to have had 3 or more outbreaks. By 1990, there were 126, 251, and 294 cities in these respective outbreak categories. These represented the fractions 0.3807, 0.7583, and 0.8882 of the original 331 cities. Here is the same data depicted graphically with year on the x-axis and fraction of all cities on the y-axis, which is effectively the LX columns, including the survival trajectories for 1, 2, and 3 outbreaks. This life table approach merits several comments. First, the life table concept provides a framework for characterizing general trends in the invasion. For example, the life table graphic shows the 60-year period between the first and last cities invaded starting in 1954. Second, this figure shows that the rate at which new cities were infested was extremely slow after the first city experienced an outbreak, with only around 60 cities, or 20% total, experiencing their first outbreak by 1980. Then the remaining 270 cities experienced their first outbreak after 30 more years. Third, the life table approach encourages comparison of invasion trajectories. For example, the graphic shows that the time between the first and second outbreaks that occurred in approximately 10% or around 30 of the cities was around 11 years. However, the time between the second and third outbreak in this same subgroup of cities was only around 3 years. Thus, a few cities are experiencing a large number of the outbreaks. Fourth, the life table approach reveals health transitions. For example, the highest frequency of cities transitioning to the less healthy state, that is, from pest-free to pest-present, was in the 1980s, with around half of the cities transitioning to pest-infested, and large fractions of many cities experiencing second and third outbreaks. I will close this module by noting that this initial framework for use of life table approach in invasion biology that we used in our book was developed more fully by Dr. Ziwa Zhao at China Agricultural University and published these two separate papers whose references are shown here. This ends this fourth module for Chapter 10.